Hey, what's up, guys? So today I want to show you how to test with the framework Catch. And this is how to test your C++ code with Catch framework. I did a video a while back, and I think it accomplished what it was supposed to do to actually test using your own like homegrown testing solution, kind of do it that way. But there's actually a testing framework that you can use. The only reason why I didn't do it back then was because compiling just took a long time. And if you want to if you want to write tests and compile your code, it just takes a really long time. But it seems to be doing better on my Mac. Right now I'm on a Mac. And so with this, I can actually run it and test it and everything. So I have a skeleton a skeleton project here that has the code. Let me show you what I have. I have basically 3 files, and I can show you what it's in each one of them. Now, Catch2, I actually downloaded from the web. You can Google Catch2, and if you don't understand what I'm saying, it's Catch2. Just Google it, and you can see it, and I can show you what that looks like. And so if I show you what's in Catch2, you can see that it's just Catch2 generated by the people that create Catch. So nothing to see there. It just provides a framework and a lot of different things. And so the other thing, and I don't want to write to it, I just want to quit. So the other thing I want to show you is what I have for the main. So in the main, we take a look at that main. And I just have a few things that are significant here. Now, I've added a few things here that you may or may not need, like file stream, IStream, and so on. And let me move these so they look all uniform. So one of the big things here is the define of Catch config runner. What this does is basically it configures Catch to use this main instead of its own main, because then that'll give you problems if you try to run Catch and you're actually trying to run Catch, because Catch provides its own main, which means you don't have to provide your main. This is a way to do it so that you can do your own main. And the other thing here is that I'm getting some weird message from my computer. Okay. So anyway, so here what I have is the Catch, the main, and you notice that I just have a basic main that has argc and argv, and with that, I can run the test. Now here I'm just checking to see if there's at least one argument, right? If there's one argument, which there always is, because the main exe is one argument, and then it'll run the Catch. So when there's no arguments, running tests, and then it will run Catch. And basically this is just saying, hey, run it. This is immediate feedback to basically that you have to press enter to quit cin.get, and it'll return. And if something goes wrong with Catch, it'll log it here. But if you have more arguments, for example, you may have files or something like that, you need at least more arguments, and it'll run the main program. It runs to the arguments. So let's take a look what this looks like when I compile it and build it. So this is it for the main. And before we actually run it, let me go ahead and show you what's in the test file. There's not much in the test file. And another thing about this is, don't worry so much about if you can read this or if you miss something, for example, in the code, because I plan to update it, and I'll post a link up to GitHub so that you can actually download the code and run this on your own. So what I have here is, let's take a look. Okay, so I don't have a lot going on in this Catch. I have a few things that I included in here. One of the key things here is that I have to include the Catch-HPP. And I always like to do using namespace std. But here I just have a test case, and I can have multiple test cases in here. And within each test case, multiple sections that test different things. I'm not actually testing my code right now. I'm just testing the string to show what it does when it fails. And we'll get into that. We'll create our own linked list, and and all of that. So these are the basics. If you just want to set up, here's the setup. But if you want to see how to put it to work when we create our own linked list, just stick around and we'll do that. But let's go ahead and run it. So let's go ahead and, first of all, we got to compile it. So I have so many commands here. So this is the basic command for G++ and C++11 to run it. And I like to create my programs as exe, even though exe is more of a Windows thing. I just like to have it just so that I know that's the executable and not something else. So it's up to you. Normally we don't add the exe in Linux systems, but I just like to add it because it allows me to see that I have an executable. So this is what's going to compile it. And notice that it takes a little while. It does take a little while to compile because, like I said, catch, it's not really so much that the main is taking a long time, but it's really that the catch is taking a little while. That wasn't too bad. On Windows, I really had a big problem and it was really taking a long time. So now if I want to run this executable, now if I look at my executable, notice that before I just had catch HPP, main CPP, and test CPP. But now if I do an LS, notice that I have a P1 exe because it compiled and produced that. So when I run it with no arguments, and you can see that the test failed and it expanded. The cool thing about catch is that it expands it. On my homegrown framework, it didn't expand. You actually had to more of a compare, and it didn't need to expand because you already had the values when you test it. But in this case, you just said an equality operation, and it will show if it'll expand it, if it's false or whatever. So it's got to be Boolean. So full does not equal bar, so it fails. And like I said, catch is waiting for my input. And then once I enter a key, it finishes. Now, the other thing about this is that if I was to run P1exe with really any argument, because I'm not checking the specific type of argument. Now, in your case, you might, you may have an input file, or you may have a flag, or you may have whatever, and then you need to parse your args. But in this case, it doesn't matter. I can put whatever. It doesn't matter. As long as it's got more than one, then it's going to run the main program, right? Because I didn't add the exe, so it has to be exe. And you notice the main program is called, says main program logic goes here, program called with args foo. Okay, so let's go ahead and get started. Let's create a linked list, and we'll test it along the way. So first thing we want to do for our linked list is, and I'm going to do it, I'm not going to separate the two. You can separate the two, but I'm just going to create a simple linked list just to demonstrate how it works. And let's go from there. Let's create it all in line and as a HPP file. We're not going to separate it. We're not going to bother with that. If you want to see that, how you separate your CPP files and your HPP files, that's up to you. But right now, I'm just going to go ahead and create a list. I'll call it an FC list .hpp. And then I'm going to go into, we'll jump right into it. So let's go ahead and begin modifying our list. First thing we want to do in this case is add our defines. So the first thing we want to do is, if not define, is the list HPP. We want to define it. And I got a typo there. And then we'll end our define. And we'll go ahead and create our HPP list. And let's go ahead and take a class, and we'll call it FZ list. And this is our list. And the first thing we want to do is create a private something. We're going to private section and a public section. And some things that the list needs to have is, for example, the constructor. So we'll put a constructor that's FZ list, and we'll just have an empty constructor. And then we'll have an empty destructor. We won't have anything there just yet. And then we can have an add. Let's think of what a list does, right? So normally with the list, you're going to be inserting, adding, creating, whatever, right? And so what type of list is this? We don't want to get into generic templates and all that. So we're just going to make it very simple. It's just going to be a list of pointers of integer types, right? But in order to do that, we also need another class called, and we probably have to define it. Since we're doing this, we'll have to define the class for the node here. So we'll have a node, and we'll just give it FC node. And let's make it really simple. In our case, we'll just make it an integer. The data is going to have data. So we'll say data. And then we'll have the node, which will be an FC node, pointer to next. And we don't want to add, we don't want to, and we want to make this stuff public. We want to access it directly. Do we really need to modify the data and everything? Do we really need to protect it? Probably you should, okay? But we're not going to do that. We're just going to keep it all very simple just to illustrate the purpose of this. So we'll make this in the public section. And we'll create a constructor for the data. So we'll say FC node, and we'll provide the data, and we'll provide the next. So FC node next, and very simply, we'll say this data equals data, and we'll say that this next equals next. Okay. And maybe the first thing that we want to add to our test to see if this actually works is to see if our nodes even work with our next. So the first thing we may want to test is the node. You notice we have everything public and we can access things directly, and we don't have anything defined const. One of the problems with this though, and I just thought about it, is that in most classes, you'll have to define something that says that you shouldn't modify certain things, like if you want to access next and all of that. So then we'd have to protect it. So in this case, we may want to take, we may want to actually take this and say, and paste it here. And the reason for that is because we will need to test our code. So we'll make these private. And let's add a space in between here. So part of the reason for that is because we want to have those private, because in C++, you do have, it will come into play that some of these you have to provide, you know, separate like const functions and stuff, so that you can't modify the code or the internal workings, the internal state of the node. So let's go ahead and create these real quick. This so wrong language. Okay, so the first thing we want to do is, let's provide the setters first. So set data. Set data. And we'll just provide in data. We'll just inline it. Then we'll say this data equals data. And we'll say same thing for set next. And we'll have an FC node. We'll say this next equals next, and we can actually put them in new lines to make them all look more appealing. And actually, see, it helps you see problems. Like right here, I have a problem with this. Should have been a curly brace, and there's no semicolon there, and then same thing with this over here. So let's put it in a new line. And same thing with this, it doesn't need the semicolon at the end. So now we need we have the setters, now we get the getters. So now for the getter, of course, is int get data. And this will just be, it'll return so it'll return data. And this is where I'm saying that this is where you actually need to have const, because you know it doesn't modify it. And you'll need that. C++ real picky about this kind of thing. So then the thing that we need is the node. So there we have a node, okay? And one of the things that we want to do, let's go ahead and test out our node. Let's see if this builds. Now our class should be good enough to compile here. We have a lot of space in between here and here. So let's see, one thing that I see wrong with this is this. And let's see what that looks like. I think we got it, but we might not. I always like to, for some reason, I always like to include, even though I may not need it. And I like to just say using STV, okay? I think this is fine. Class, FZ node, okay. Let's go ahead and save this. And let's go ahead and add it to our tests. Let's go ahead and open up our tests. And that would be we have tests. Okay, so let's go ahead and add that to our tests. And let's include that should be enough to test it. So let's go ahead and also add a let's go ahead and add a test case. So here we're gonna have the node. So we're just gonna say we're gonna add the node. Oops, I mean to do that. I meant to do this. Node. I just put node, and we'll close it off. And you don't necessarily have to have sections. It's just good to have sections that way we can wrap everything in one, and we can name our sections. So in this case, we are going to test initial node. We'll say initialize. We'll call this the initialize. And what we need to have here is declare an SE node. And it'll probably be a node pointer equals new FZ node. And we know it needs data, or we can say no pointer. But let's go with FZ node. And we are going to pass it a 1. And next, we're going to pass it a no pointer. And we are going to test. And now this is where it gets into the testing. So in order to write your test, you have to say require. And we can say, for example, node get data equals 1, okay? And that should be good for that. And then another test will be node get next, and it should be equal to no pointer. So now let's see if our stuff builds. Let's go ahead and save this. And now we are going to recompile. We're going to recompile. And one thing we can do is create a little make file so that we don't have to do this every time. It'll just run right through, but let's go ahead and do this. So it's going to compile and give us the errors if we have any. Let's see what it does. Okay, include test CPP, test HPP not found. Okay, yeah, that's a problem in tests. Let's go take a look at tests because I think I've been to say catch HPP, not, I don't even know why I included that. It should have been not test, but rather the FZ list HPP. So let's take a look at tested HPP, VM test.hpp. Oh, we don't want to save this. I typed in the wrong thing. So let's go VM test.cpp. And I'm including test HPP. Well, there's no test HPP, there's catch. What I meant to insert here was not test HPP, but rather FZ list.hpp. So let's go ahead and try to compile that again. So it takes a little while, but it's not actually as bad as it was on my Windows machine. So, okay, so now it's having a problem. It says no matching constructor for FC node, where we're passing an integer. The implicit copying constructor not viable requires. So one of the things that we didn't do, and I guess all classes need the copy constructors in order to do all this. And I didn't even say new, I should have said new. So what I need to do, a couple of issues here. So let's go edit the, first off, let's go fix the node, which is in the FC list. Isn't it? Oh, let me see. Oh, it's FC list. So it's VM FC list HPP. So one of the things that you normally got to have for these classes in C++ is the default constructor. So let's create a default constructor, which does nothing. Basically, in this case, all we wanted to do is set the data to 0 and set the next equal to no pointer. The other thing that we want to do is we need to have a copy constructor, and copy constructor looks something like this. And you need to have need to have something like this. And then we copy over whatever's in the other node. Now, this is where you got to be kind of careful, because if we copy a node over, we don't necessarily want to destroy what the other node has. So when you have next, if you copy it over and pass it around, what do you want to have? And so you got to be careful with that. Okay. So if we were going to copy this node, we would copy the data. But let me think about that. If you were copying the node, I guess because it's copying, you do want to copy the next. And that could lead us to memory leaks, but we'll have to test this for something like that. This data, and I need to say equals other dot data, and this next equals other dot next. Okay. The other thing that we need to do is the operator, the assignment operator. So we need to say something like fc node, like this. And I forget how to do operators. Let me look that up real quick because I always forget operator overload. And I'm searching while you're on that screen. Let me see the operator overloading. I just forget the syntax. That's all it is. Constant other. Okay, operator. Okay, so that's how it's done. So it's just fc node and operator, and then const fc node other. And when you copy something over, you have to say same thing, just like we did for the copy constructor. We have to say data equals other dot data. And that's why I wanted to kind of create it as a struct initially and not worry about this, because it can get a little crazy. But just because you had to keep track of who's deleting. But the other thing that we need to return is we need to return this is tricky. Let me see, is that what I saw? Because, okay, so it is that. So I just need to return this. So let me go ahead and return the value of this. And that should be sufficient. Now, that's sufficient here. But we need to go fix our test CPP. I think we do. So let's go ahead and fix our test CPP. I think because one of the things that we didn't do here, we just said equals node. Well, this is not going to work because it's just say equal new. Oh, not two equals, but one equals new node. So let's go ahead and save all this. Let's go ahead and build it again. And like I said, this is one of the reasons why I didn't do it the last time, because it takes so long. So now this is saying, hey, you don't have a matching. So it has data. Oh, I see my error. I put the pointer behind the FC node. I can't believe I did that. That happens sometimes. So let me fix that in the test CPP. Oh, it's not in test CPP. Actually, it's in the it's in the node itself. So let's go ahead and take and it's in the node here. We did, not we, but me. I did screw this up. I don't know why. Okay, and I think that does it. Let's see. I think that'll do it. Okay, so let's go ahead and let's try it again. That's one of the things about it is that I don't like about Catch is because it takes so long to build that it doesn't allow you to be flexible. Like normally you make a small change and you test. And that's the whole idea of TDD is that you test, you write code, you test, you write code. You don't write any new code until the, if the tests fail, then that's when you write code. But if everything's passing, you don't write new code, you write another failing test. So in here in the HPP file, we got to include HPP. I don't know why we have that, but that's in test CPP. So let's go fix that. So let's get rid of oh, you know what? Let's do this. Let's leave that alone because I really want it to be like that. The only problem is that the file, if you notice, I have an uppercase Z on it. So let's go ahead and do this and rename it to this. And let's go ahead and try to build and see if it works this time. And I renamed it because of rules that's the way it should be. So now if we see it run, so we should be able to now run our P1 exe and see if our test actually passed. So we see here that we have foo and bar failed. Well, those are old cases, right? We don't care about the foo and bar. We don't care, but we have one test that passed, two tests that passed, and one failed. So let's go get rid of that stuff. That was just the starting point in our test. So let's go ahead and fix that in our tests. Let's get rid of the linked list test. Well, let's not get rid of them because we're gonna need something for the test. So this apparently this passed. We want them to all to be green, but let's start writing stuff for our linked list. Yeah, that would be good to write something for our linked list so we have something. So we did a test for the node and it's like it does work. Let's go ahead and write some more tests. Let's get rid of this. As a matter of fact, let's comment this out or fix it so that it passes, right? I intentionally put something failing. Let's make sure it passes and then save it. And let's add some more tests to this. So we added this. Now let's test to see if, let's test to see if our nodes will actually link things up. So let's say link multiple, right? So we'll link a few and we'll rewrite this. So we have a section there. And this time what we're gonna do is we're gonna say every node, we'll call it the it's like the top, the head, whatever, right? So you want to call it the beginning, right? We'll just call it the beginning. And we'll do like we did before, every node, and we pass it a 1 and a no pointer. And we'll create another node, okay? And we'll say beginning set next, right? And we'll create a new FZ node with a 2 and the no pointer. And we'll go to beginning, get next, and that'll be the actual 2 is what we're getting, get next, and set next. And we'll go ahead and set a new node. We'll put 3. And we have the beginning. So now our test, we can require, and we can say that node, not node because we don't have node, we have beginning. The get data is the first one is going to be equal to 1. We need that test. The next one, we need to make sure that the next one is a 2, and then the one after that is a 3. So we're going to say get next, get data equals 2. And for the third one, we'll say beginning, get next, get data equals 3. And the last one, we'll have null at the end. So we have, this one is wrong. We should have said get next, get next. So this should have been get next and then get data. So this one is going to get next and not get data anymore at this point. It's going to say get next. And it's going to be equal to no pointer. Okay, so those are our tests to see if they actually link up like they're supposed to. And I think we got everything right. So let's go ahead and save it. And let's go ahead and, so right now we should have everything passing. We should have no failing tests and all our tests should be passing, but we'll see if that's the case. But like I said, every time you do this, you have to rebuild. And for some reason, the takes it a long time. It's like I said, it's the catch HPP file. And let's see, FC node is a pointer. Did you mean to use an arrow? Oh, so I said set next, so I shouldn't say dot. That's a rookie mistake. But when you work with a lot of different languages, that's what you run into. So coming from C#, using it so much, then it's kind of a challenge sometimes when you start getting to C++ because it makes a difference between pointers and just classes. So let's fix it, and that's in the, that should be in the test CPP. I'm trying to, oh yeah, VM test CPP. So where did I say this? Okay, here. And I have another one. And I don't think I did it anywhere else. So let's go ahead and save it. Go ahead and build it again. And I'm only going to write a few tests for the linked list. Like I said, I'm going to post the code. And if you want to fork it and try it, it'll be on you. So let's see what this says now. Expected. Oh yeah, missing parentheses on all those 3, the closing parentheses. What happens when you're not working with an ID. I do highly recommend working with an ID. It's just an easier way to share for me using this, but this is not typically the way I work. I usually work with, on Windows, I work with Visual Studio, which is by far for me the best experience, but I haven't really had one. On Mac, I typically tend to work with, right now, just Xcode, but I also use Visual Studio Code, except Visual Studio Code, it can be painful to set up for C++. You end up compiling from the command line and sometimes setting up for debugging and all that. You have to do it for every project, so it becomes a pain. Eclipse is also a problem. C-Line, I had problems with installing, making sure that the lids were hitting right and everything. So my best bet right now, I think, is Xcode. Even though I'm not a big fan, but it's probably the best thing that I've tried on the Mac. So anyway, let's go fix this. Closing parentheses on all those lines, 21, 22. So let's go fix this. So let's go fix those tests. Yeah, that's so obvious. Set next, it's in this line. Oh yeah, and the other thing is I'm working in Vim, and if you want to show the lines, you could actually say set number, because I know you'll have a problem seeing the lines. So you can see the lines there. And so it said 21 and 22 were the problems, and they sure are. So that needed it, and this needed it. And we'll go ahead and save it. And we'll hit and do this. And the other thing we can do, I think we can do something like this. I think that actually redirects the output. I don't want the output to go there. I'm not sure how to write this. I think you have to say cat, whatever. I'm not gonna do that. What I was thinking about doing is making like a quick little make file so that I don't have to type all this at the command line every time. So let's go ahead and run our test. And we have 7 assertions, all our tests pass. So at this point, you know enough about how to test, how to run everything, how to set up everything. So at this point, if you watched this far, well, congratulations, because now you have something to build upon. Like I said, I'm going to commit the code. I'm just going to write maybe 1 or 2 tests for the list. And really, that's all I'm going to do. Just maybe like an add or something like that. So let's go ahead and do that. Oops. I just want my input. If you don't want that showing up, you can modify your main to not have that. And I'll show you in a quick second where it is. So notice how I have to press enter in order for that program to end. But here's what you need to do to get rid of that. So let me show you real quick. And I think I do want to get rid of that. Immediate feedback. So if I get rid of that, I think that's what takes, I think that's what causes that pause to not let the test just finish. Of course, on some systems, like when you're building on Visual Studio and stuff like that, you want that pause because it pops up the console dialog and then it shows it to you and it hides right away. You don't see what happens. So sometimes you need that when you're like in an IDE. But since we're here directly on the command line, then I don't need to do that. I just go ahead and run this. And see, now it didn't wait for me. It just went ahead and told me what was wrong. So let's go ahead and add one more test, like I said, to the FC list. So let's go ahead and it's HPP. Let's go ahead and add one more test to one more scenario. So the way TDD is described is that it's supposed to be something like red, green refactor. What that means is you write a failing test, you fix that test, write code to fix it, and then it goes green, and then you can refactor, to make it better or whatever. And then you write another test, make it red. So in other words, your tests have to fail first. And it's a good idea for your test to fail because that way you know for certain that your test framework is working. There's been situations where like the framework's not working, depending on where you are. I'm not saying with Catch, but in other frameworks, and you think that your tests are running and they're not really running. So one of the first things we need to have is we need to have the beginning. So we're going to need an FC node, and it's just going to be beginning. And in the constructor, we're going to we're going to set it to null. So we're just going to set beginning. Let's not initialize, that's the bad. I just don't like writing that big long word. Equals no pointer, right? Or not equals, but assign no pointer to it. And the destructor gets a little interesting, and this is not the tutorial on linked list. It's really on testing. But if you know anything about that, is that you have to destroy this. And so to do destroy and test, right? So one of the first things that we want to do to our list is be able to insert a node, right? So, but before we define it, like I said, it's red, green, refactor. The first thing you want to do when you're testing is write enough code for the code to compile, but the test should fail. So to insert a node, we just say insert, and typically a lot of times you hide like the details of the pointers and all that, the nodes. So we're just going to say insert, and we just pass it data. So in this case, since we're working with FC nodes, the data is int, and item, we just call it item. And we don't do anything, right? But this is not going to allow us to test it because we need to be able to see the list. And so we need to be able to find something in the list, right? So we insert, but we're not doing anything with it. So there's another thing that we have to do is we need to be able to find, right? And so this is the tricky one that we're going to have to insert and be able to find what we have, and it's going to return to us what index it finds it at. So like in this case, the find index of item, right? So returns, actually it should just return the item. Let's say returns item or null and not, and see, we can't return null, we didn't make templates. So we'll just return -1 if not found. We'll just say -1 is our flat, right? So, or we could say some random negative number, right? So we'll say find, and we'll tell it what to find, target, and we could tell it the index or where we find it, but let's just say the index. Let's just stay uniform with norm, index or -1. So we can actually take our beginning and we can say FC node. Okay, let's not do this yet. Let's just return -1, just to kind of give you an idea. And this is why I find Catch so painful, because I have to build this, compile it, and make it go green and write my test. So now I need to go write my test. I wrote enough code to write my test because I have an insert and a find. So now when I go to my test, I'm going to test my linked list. And now I'm going to, I'm not sure what to do about empty lists. I might have to come back to that. But I do have an idea of what I want here is insert first item. We'll call it that. And we'll write the test for it. And we'll say we have an empty list. List equals new FC list. And we'll say list. If we're doing new list, then we probably need to make it a pointer. And then we'll say insert we'll say 1. And insert may be a bad name because insert is misleading. Like, where are you inserting? Typically, when you insert, you got to think in terms of what would you do? Like, insert indicates like, I want to insert it somewhere where I tell it. So there's already terms for example, for pushback, or in like in other languages, shift and unshift and stuff like that. So maybe we shouldn't call it insert. Maybe we should call it pushback. So let's call it pushback for that reason. Let's call this pushback. Let's call it pushback. We'll have to change our list, of course, to reflect the change. Pushback. We'll call it pushback 2. So now with these 2 pushbacks, I should be able to find those items. So I should say list, not list, but require. And I should say list, find, and I'm finding 1, and it should be at index 0, right? So then require list, find, and it should be at index 1. One thing about these finds sometimes is that you want to find at the beginning, in the middle, and at the end. So let's put 3, that way we can have middle, beginning, and end. So let's go ahead and find 3. And it should find all those. But we didn't name it pushback. The find, we did call it find, but the pushback, we didn't call it pushback. So let's go and rename it. So let's go back to our FC list. And let's call it pushback. So this one we'll call it pushback. And you know what? While we're in here, let's create one for size. Void size. Actually, not void size, but rather int size. And for now, we'll just return 0. Okay. And we'll have to test all of these. All these things that we're writing, they'll have to be tested. But right now, what we're interested in a couple of things, in size and in the find. So let's go ahead and do this. So let's go ahead and save this. See if it compiles. Let's just get it to compile first. So it's still, on my end, it's still going. And I found an error. I misspelled section. So we'll fix that. In 49 expects a curly brace. 31. Something's wrong with 31. Oh, probably from 49, 31. So let's go fix that in test CPP. And it's again set number. So we know it's all the issues we're having are down here. So one thing about it here, we have this. We have this extra C in there. So it does that. We have a test case and we have a section. I don't know why it was complaining about curly brace. Maybe because it didn't know about the section. I think we're okay. I think it was complaining about 31 because that's the test case. We have a section here, section here. Okay, let's try it. Still it's saying that it's not matched up with something. Oh, I've been seeing the double quotes on that one. So let's go ahead and fix that. Misleading error. So what we need to have is the double quotes at the end of this. And if you're still watching, I appreciate you watching. I know some people are going to complain. I can already hear them. It's like, you're too slow, you're too long. But hey, this is actually, you know, coding, testing as you go. And you can see why sometimes development is slow. So if you're just getting into it, you may realize like, wow, it just takes, sometimes when you get things working, and that's not my normal workflow. My normal workflow is that I write code and then I come up with ideas of ways to test that the code actually works. And if I have a doubt that there's something broken, then I go and make it on purpose fail just to see that my tests are actually running. And then I do it. So, and that's so my normal workflow is to write a lot of code and then write unit tests. And that goes against TDD. That is not TDD. And sometimes TDD is a little extreme. It works for some people. I just never was able to really get into it at that level. So we should see some failing tests now. And you see that we have where it failed, the find equals 0. So we need to go fix that find. And the find, if we test the find, then we should be okay with the insert because we know the insert is working, right? So sometimes you don't need to test everything. You need to just test those things that are failing. So let's go fix that. And let's go fix it in the list. So how do we fix that? Well, we're not inserting properly. So when we insert, when we push back an item, we can say if beginning is a null pointer, then we can take and say beginning equals new FC node, and we pass the item no pointer to it, right? But if otherwise, if beginning, now we could just do it else. The tricky part about this else, and normally like the way TDD describes this is that you should not write any more tests. Like right now, this will make it pass, right? We'll be able to find one, but it won't be able to find the others. So I know in order to fix the others, we need to do this. So in order to do something like this, we need to have an FC node and we need to iterate through, and we say previous, we can say current, right? We can say current equals, we could say current equals beginning, because we know beginning has something, right? So now we say while current, and we'll say get next, not equal no pointer. Then the standard for a linked list is that you always advance current, set next, current, get next. And that's how you navigate a list. But one of the things here is that we want to make sure that we don't walk off the end. We know that once we find a current with no pointer, then we're going to take that current and we'll say current set next, right? And we're going to say mu FC node. We're going to insert a node with the data and a null pointer because it's at the end. And so now with this in place, we did the pushback, but now we have to navigate and find it. So I'm going to take these lines here, and it's how many lines? 1, 2, 3, 4, 5, 6. So it's about 6 lines. I'll take all 7. So I'll take all those 7 lines and I'll put them here. And what I do here, I don't like the way it did. And notice how I'm formatting my code. And I don't really see it. Normally in Studio, it shows you better. Like in an IDE, it shows you how you have it better. But in this case, I'd rather just kind of wing it like this. But I'm really like my code to be formatted properly because it's easier to read. If you don't format it, make sure you have it indented. Because if you're not, then it creates a bunch of problems for readability. So here I'm just looking for the beginning, right? So now the thing is, like, if I know that the head is null, so I can say if beginning equals null pointer, then I'm just going to return -1. I'm not even bothered looking. And then I'm going to start with the head, and I'm going to navigate the entire list. And I'm just going to say, in this case, it's a little bit different because I don't care if it's just, I just want to see that it's not null. So I set it to the beginning. And I want to start at the beginning. And I just want to look and see if I can find that, right? So I'm going to say if current get data equals target, I'm going to return the index where I found it, okay? So my index initially is going to be, index is going to be equal to -1. If I find it, it's going to return the index, but I need to keep track of the index. So as I walk through the list, I need to increment my index. So my index here just increments, and I will return the index. Now, as far as set next, we don't need to do anything like this. We can delete that line, and by default, we'll return -1 if we don't find it. Like if it walks off the end of the list, we'll just get rid of it. So let's see if this works. So let's see if that gets our test passing. And I know some of you come to YouTube to kind of just be taught, and you want to get to the juicy stuff. How do I do this? How do I do that? You know, this video may not be for you. This is kind of coding alongside, seeing what I'm doing, and that's just my style. That's just the way I do things. I used to not do it. I used to do it more focused and more, you know, but of course with that, probably the best thing to do would be to sign up for a course. There's plenty of courses that teach you this stuff. So that's not my intent here. My intent is to kind of show you from a different perspective, just a different way of doing things. So we know that it ran, that it compiled. So let's go ahead and, okay, so it's gonna run the test, see what it does. It's taking a long time to run the test. So maybe we did something wrong. Seems like we did something wrong. Okay. Only because of how long it's taking, it shouldn't be taking this long to walk a list with a few nodes. So I'm gonna go ahead and kill it. I'll go ahead and kill it. Looks like we gotta end this loop. So let's go take a look at our logic for the test. So somewhere where we're walking this list, probably on the insert or on the find. So here is setting next. Oh, here's our problem. Here's our problem. I don't know why I did it this way. Yeah, this is definitely a problem. I don't know what I was thinking. But believe me, I do not. I do not do drugs. So I don't know. That was like a high moment there. So it should have been this, not set next. I don't know what I was doing. That just is going to keep setting next, and it's just going to never end. So that'll leave you in the endless loop. And I don't know why I did that. And I don't know why I did that here either. Wow, this is so bad. I apologize. Why did I do that? So let's go ahead and fix that. Current equals current next. Okay, so that's what it should be. I don't know why I did that. Somebody, I can already hear the comments. Somebody's gonna really beat me up, like, what were you doing? You know, and teaching bad stuff. And if you watched it up to that point, I apologize. You probably just, yeah. So let's go ahead and take this and see if we can fix that. Okay, so let's go ahead and run it. And there we go. All our tests pass. And of course, you can keep going and add more tests, add more functionality, and just keep adding more functionality and keep adding more tests. And you know, you could keep going forever. But like I said, I'm going to post this code so you can have it. And one thing about it is, like, there's so many things here. And for example, in the FC list that we don't have implemented and we don't have tested. Okay, because one of the things we don't have is, for example, the size. And this class is not about linked lists, but certainly there's things that can make it better. Like, for example, tracking the end of the list, and you can track the end of the list, and that way you don't have to worry about it. And then tracking the size. Personally, I like to track the size of the list, and just, you know, instead of counting, you can navigate and get a count. But personally, I like to get a size. Right now, if we test the size, we know it'll fail. So most of these methods, most of this functionality you want to test. Of course, like for example, with this one, with the pushback, well, how can you really test this? Well, there's two ways you can test it. One of them is through the size, which will fail right now because we're just returning 0. And the other one is to find the target, right? And the other thing about the target is, like, well, we need to do negative testing too, see that it finds something else. So for example, the other thing that we need to add in our test is tell us that if there's something not there. So let's go back into our test. So it should also tell us, that way we know that, hey, it doesn't find something that's not there. So if we go here, for example, let's say that we were looking for -1. Will it find it? Will it not find it? It should not find it, right? Because we're returning indexes. If it returns -1 on -1, it should be equal to -1. If we look for another value that's not there, let's say we look for the value 4, which is not there, it should return -1. So those are two tests that you may want to add for this test. Really said we named it find first item. So we really probably should rename this test to be say we want to test pushback. And the test is just to kind of help you organize your test. So we have this organized. And so if it passes with this -1, defining that, then we know that, hey, we're not getting any false positives, because that's important too. So let's go ahead and run this real quick. And see, once you get everything working, that's the beauty of it. Once you got everything working, you can add tests and you can add more tests, or you can go and write a bunch of code and flow a little bit faster than we've been flowing here. So you notice that the test passed and everything's good to go. And like I said, just to kind of recap a little bit, let's take a look at the main. We have our includes here. We have our main in this case. We can either run our test or run the program. One thing about it is that we run the program when we run the test when there's no arguments. And one of the things about it is the reason we do it, part of that is because when we actually call the session run, it passes argc and argv. If you pass something weird here, Catch is going to try to do something with it. Maybe there will be a part 3 to explain what some of those things do, because even right now, I don't know what they do, but I like to know, like, what do they do when you pass these, but it'll kind of hang up. So that's why with no arguments, which argc is the first argument is really just the name of the executable. But if you do pass any arguments at all, it'll do this. And of course, argv, you could have like an input file, output file, you could have flags, all this other stuff, and your main program will run. So like, for example, if we run it right now, if we run it right now with an actual argument, and let's say -o, it doesn't care. Foobar, testing, -- my file equals that file, txt. You can do something with those arguments. Notice how the program knows, like, hey, you call me with -o, with foobar, with testing, with my file, and so on. So that's the reason that you want to have that. And it's like, that may not work for you. Maybe you want your program to run with no arguments, but then testing is getting in the way. So that's where you would need to investigate, what does it do with the flags? I'm just letting you know that if you pass anything and then you pass those argv, maybe you should create a different argv for it so that you don't pass that into it. If you want to flip everything around, you'll find out. If you find yourself where it hangs, then you know why. Anyway, thanks for watching. If you like this video, really give it a thumbs up. It really helps me. I'm just starting out. I mean, I've had the channel for a little while, but it's really helped me, and I would like to see more. If you want to see more content, drop a comment. If you need help, get stuck. Right now, you have the luxury that you can reach out to me, and I may even be able to help you. We can jump on a Zoom and help or whatever. And so if you really like it, give it a thumbs up, subscribe. And if you don't, give it 2 thumbs down and put it on the comments. But if you give it a thumbs down, let me know why. I'd like to know why. Okay, thank you.